Hi everyone, Dankman here. Notes today are going to be about something called the order of operations. Okay? And the order of operations is a way of thinking about how to do calculations. Today is Tuesday, March 3rd, 2020. I'll start with just an example of why this thing matters. It's a way to think about doing calculations. So let's start with this example just to show you why this thing matters. 2 plus 3 times 4. How could we calculate how much this is worth? On the one hand, I could add 2 plus 3 first. In that case, I would get 2 plus 3 is 5, and 5 times 4 is 20. However, for very good reason, some people like to do multiplication first, in which case we would get 3 times 4 is 12, and 2 plus 12 is 14. And either way could be considered valid. Do we want to go from left to right? Do we want to do addition first? Do we want to do multiplication first? So we have to make a decision as mathematicians about which way we want to do things so that we have an agreement that this expression is always worth the same amount. We can't have a good way of doing math if this expression here, 2 plus 3 times 4, is sometimes worth 20 and sometimes worth 14. And because of the order of operations, all mathematicians agree that the one on the right is the correct way of doing it, and the one on the left is not the way we're going to do it. So let's learn why that is. To talk about the order of operations, we have to talk about what operations are. Okay? There are 4 basic ones that you'll always remember, I think, for the rest of your life. Add, subtract, multiply, and divide. There are other kinds of operations as well, and we're going to focus on this 5th operation called exponents, like 3 to the power of 2. Okay? This thing right here is an exponent, the 2. An order of operations is basically about deciding how to perform these operations when you have options about what order to go in, like in the opening example. So let's hop right to it. You've heard this before. There's an acronym for how to think about what order to do stuff in, okay? And it's like this. We do parentheses first. These are things that group together expressions, okay? Then we do our exponents. Followed by multiplication and division. And I'll talk to you more about this later, about why it doesn't actually matter which order you do multiplication and division in. However, multiplication and division have to come before addition and subtraction. And so, the order of operations runs from the top to the bottom, where whatever is higher on this list gets done before anything that's lower on the list. And that's how the order goes. Let's take a couple of examples. The first example will involve parentheses, so that you can get used to those. The first example will involve 6 times the group 3 plus 4. Anything in parentheses, like the 3 plus 4, I'll refer to as a group. So you may want to multiply the 6 times the 3 first, okay? Because they're next to each other. But the addition, which is supposed to come after multiplication, is actually inside of parentheses. And so, if it's in parentheses, we have to treat it like a group and take care of what's ever in the parentheses first. So we're actually going to add 3 plus 4 first. And then we'll do 6 times 7, which is 42. Okay, that's example number 1. Example number 2. We'll go ahead and look at a problem with some exponents, okay? And we're going to do 4 to the power 2 divided by 2 to the power 3, okay? Pardon me, divided by 2 to the power 2, okay? So you may want to do the division first, 4 divided by 2 first, but we're actually going to do the exponents first. And let's look at what an exponent is. 4 to the second power means to multiply 4 times itself. And 2 to the second power means to multiply 2 times itself. So 4 to the second, or 4 squared, means 4 times 4. And 2 to the second, or 2 squared, means 2 times 2. So in the top, we get 4 times 4, which is 16. And in the bottom, we get 4. And 16 divided by 4 is 4. So our final answer is 4. Let's do one more example. Example number 3. We'll do 3 times 6 minus 5 to the second power. Okay? So the first thing we'll do are exponents. 3 times 6 minus, and 5 squared, or 5 to the second power, means 5 times 5. So that'll give us 25. 3 times 6 is 18. And 18 minus 25 is negative 7. And that's our third example. So reviewing what we've done, we know that there are examples of expressions where we want to be able to always come out with the same value. And so we have to agree about what order we should do things in so that we don't get different answers depending on how we do it. The different kinds of operations you may have learned about are add, subtract, multiply, and divide, and also exponents. Okay? And this order of operations, which some people memorize as PEMDAS, tells you to go from top to bottom, doing whatever is up high before you do whatever is down low. And three examples are examples of how you might do this. Now, these examples may not make sense to you yet, and that's okay. There's really only one way to get good at evaluating expressions or finding out how much an expression is worth, and that's to practice it as many times as it takes, which often is a couple weeks of practice of doing it a little bit every day. So let's begin with the handout. Go ahead and unplug and get ready to use your notes to do some order of operations evaluating expressions.